Next topic is offline storage. So here we are going to talk about the need for offline web applications, and we are going to take a look at HTML5 offline storage types, and then we are going to look into each of these offline storage types in detail, starting with the application cache, local and session storage, indexed DB, and local file system access. And then we are going to see how you can ask for more space using Quota API. And then we are going to see how you can get an event, meaning how your browser can receive an event when there is a connection or the disconnection of the network. Okay, so offline web applications. So your web applications, by the way, when I say web applications, I'm talking about browser-based applications, need to function without connectivity. The reason people still use desktop application is because they can use those applications offline. Now, in order to replace these desktop applications completely, your web applications need to support offline usage of the applications. So in order to support offline-based operation, the web application needs to save the data somewhere so that those data can be accessed even when there is no connection to the server. So your web application needs to present consistent UI to a user so that even if they are offline, they can still use some of your applications. So moving forward, you should actually design your web applications to be considered to be used offline as well. So build your applications with offline in mind first. Okay, so let's take a look at HTML5 offline storage types and technologies. So in terms of storage type, they can be categorized into three different types. Temporary, sometimes it's called the transient type, and persistent type, and unlimited type. So temporary, well actually temporary and persistent, those are actually kind of opposite side of it. Okay, so unlimited is probably a different kind. So temporary is automatically given to each application without application asking for it. So it's shared among all web applications using that browser. And the shared pool can be up to half of the available disk space as a default. Okay. The persistent stays in the browser unless the user expands it or clears it. Okay. An application can have a larger quota for persistent storage than temporary storage, but it must restart storage, request the storage using Quota API, and user has to grant it. Unlimited storage is similar to persistent storage, but at this point is only experimental, only available to Chrome-based applications. Again, this is actually based on the December 2013. So I don't think that nothing has been changed that much since then. Okay, so in terms of offline storage technologies, you can think of these four technologies represent HTML5 offline storage technologies: application cache, local and session storage, index DB, and local file system. There is what is called the Web SQL, which is supported in Chrome. That is not a standard, but it is supported in Chrome. So if you include that, we have 5 different storage technologies to explore. So let's start with the application cache. Application cache. So why we need application cache? Okay. The old browsers, meaning the browsers that do not have application cache support, they have a caching schemes, but they are unreliable, and they don't always work as you might expect. Okay, and another deficiency of that is that it doesn't allow application-specific control for the cache. Okay, so it's just provided by the browser, and there is no application-specific control by developers. Okay. Now, application cache enables offline browsing, so users can navigate your full application even when they are offline by saving the data files locally in application cache. And it will result in higher speed, higher response to the user because the browser will actually get the data from the cached resources rather than going to the server. And higher speed, basically cached resources are local, therefore they get loaded faster. So this is actually loading time. And again, reduce the server load. The browser will actually get the data from the local application cache rather than from the server. So server load is going to be reduced. Okay. Now, how do you specify which files need to be cached? That is specified in a file called the application cache manifest file. Okay, so this is application cache manifest file. So what is that file? So application cache manifest file is the location, is the file in which you specify which application files or data files you want the browser to cache and make them available to offline uses. Okay. Now, where do you specify the location of this application cache manifest file? You can specify in the HTML tag like this using manifest attributes. So in the HTML document, you start with the HTML here. And if you want to support the application cache, then you specify the name of the application cache using manifest attribute. Okay, so this one, the name of the file can be anything. Hold a second, it looks like so I was talking about the how you specify the location of your cache manifest file. So basically, you are going to use manifest attribute in HTML tag, and then you specify the name of the file. Okay, so the name of the file can be anything. Okay. Okay, so in the application cache manifest file, you could have 3 different sections, and each section will be marked with a header. Okay, so the first header is going to be cache. In fact, before the cache, you could have cache manifest. Okay, so if you don't have this cache header, then it's automatically assumed that entries are belonging to this cache section. What it means is that the files specified in the cache section, those are the ones that will be cached. Okay, so they are explicitly cached after they are downloaded for the first time. The network section, so this is the header for network section. So these are resources that require connection to the server regardless, meaning the resources specified in this section will always try to get from the server. Okay, so all requests to these resources bypass the cache, even if the user is offline. Okay, by the way, you can use the wildcard notation. Okay, so if you happen to have a resource that you always want the user to get from the server, then you specify explicitly under network section. Okay, why is going on? So let's actually continue again. Okay. The fallback section is optional, and basically it's optional setting specifying fallback pages if resource is inaccessible. Okay, so if network connection is disconnected, meaning offline, and if the file is not available from the cache, and then this fallback option, the file, the first URL is a resource. If this resource is not available, then the second is a fallback. So the second thing will be actually used. It could be just a string message that gets displayed to the browser or something like that. Okay. Both URIs must be relative and from the same origin as the manifest file, and wildcards may be used. Yeah, in terms of the same origin, again, we're going to actually talk about the concept of same origin later on in detail. Okay. All right. I just want to make sure you guys hear me okay. My audio connection is lost. Attempting to reconnect now. What is going on? So let's actually continue. Now this cache, app cache, could be updated. Okay, in one of these 3 cases. The first case is user manually clears the browser's data storage, meaning app cache, user can say, clear all the app cache data. In that case, data will be reloaded from the server. The second case is the manifest file is modified. Okay, if the manifest file is modified, then things will be reloaded and cached. Okay, now one thing I want you to note is that updating data file itself, okay, does not update the cache. Okay, so updating a data file listed in the manifest does not mean the browser will recache the resource. The manifest file itself must be altered. Okay. Come on. Ooh, the recording. So updating cache. So there are three different cases where the data in the application cache will be updated. The first case is obvious. User clears the cache. Then the next time the file is accessed, it will be reloaded and cached again. The second case is tricky. So in this case, manifest file is modified. If the manifest file is modified, then the things will be reloaded and cached. Again, changing the file itself. Sorry about that. Oops. Changing the file itself does not necessarily refresh the cache. Okay. And the app cache can be programmatically cleared and updated. Programmatic control. The browser provides application cache object. So Windows has application cache property, which points the application cache object. That is the object you can use to programmatically control the application app cache, the app cache. So you get the app cache object and we save in app cache, and then you can actually take a look at the status of the cache. So the status of the cache could be one of these 1, 2, 3, 4, 5, 6, 7. Uncached, idle, checking, downloading, update, ready, and obsolete. So one of these 6 states. App cache events are fired by the default by the browser, especially for Chrome. So whenever things are cached, whenever actually app cache events are occurring, you will actually see the messages that are coming from the browser by default. Okay. You can also register custom event handlers to cache these events. Okay, so if you want to do something on your own, you can actually register your own event handler. So in this case, so you have app cache event, app cache object, and then we can call add event listener for cache. Whenever the cache event occurs, I want to invoke handle cache event handler. Same thing. Whenever caching event, checking event occurs, I want to call the handle cache event handler. So we actually, in this case, in this example, the same event handler for each of this state change. Okay. So we're gonna actually try this one in the hands-on app. You can take a look at the app cache contents in Chrome by actually calling, by specifying Chrome app cache internals. So let me just show you here. So Chrome, oops. App cache internals. So right now, I have, in fact, the two cache. So here, this is the, so this is the cache manifest, and underneath, these are files that are considered on the cache section. Okay, and let me see if there are any network. Okay, so everything else, it goes to network. Okay. Let's see, and this one is Chrome. Okay, so nothing much. So yeah, so this is the network cache manifest, and in this case we have a network first and cache section. So these files need to be cached. Everything else is has to go to the network. Okay. Okay, so that's the way you can actually take a look at the contents of your app cache. All right, so let's do exercise 1. So we're going to play around with the application cache. So we're gonna actually try Angry Bird first, okay? And again, you're going to install it. And then we're gonna take a look at the contents, okay? Okay, so now, even if I click this, and then I should actually say Chrome add cache internals. Interesting. I should have. Yeah, I expect the. Let's actually try one more time. The Angry Bird should actually have been cached. So this one, and oh, so yeah, you can certainly try disconnecting internet connection, but you're gonna lose me, okay? And then play the game off. You can certainly play the offline, and then you should actually see Angry Bird manifest here, like this, and then I should actually see all. So all these MP3 files are cached. You can also take a look at the actual entries, okay? And those entries are in fact the files, okay? So I'm kind of puzzled why it didn't actually save it. Let me actually try one more time. Okay. Install. Okay, so now I'm gonna actually try from here, from caching tunnels. Yeah, this is certainly an interesting behavior. Yeah, I should actually see. Yeah, it looks like it's not cached. It's possible, the Angry Bird applications are now actually redesigned in a way that it cannot be cached. Okay, so it seems like that's what's happening. It really depends on the application. Okay, all right, so we can actually try a different thing. Yeah, so certainly I'm not sure whether I have to be offline. Yeah, so it's actually interesting behavior. So again, it depends on the application. So we're gonna actually use a different application. We're gonna actually use our own. Okay, so in the previous behavior, these are all cached. Let me know whether you have actually, in fact, the different behavior that I'm seeing here. Meaning, whether you can see the cache contents. In my case, it certainly doesn't seem to be cached. Okay. I'm going to try the Firefox. I'm going to try different browsers. See, oh, in that case, I cannot see the contents. I need a Chrome. Okay. All right. So now we are going to access our own application. So in this case, we are going to definitely see the cache contents. Now we have to actually run the HTTP server as we have done before. So let's actually go to the server here. I'm going to stop this guy. Okay, and I have to go storage, HTML5 storage, and then run the HTTP server. Okay, and okay, so I have already the in here. Okay. So we started the HTTP server, okay. And now from the browser, we are going to go to this cache simple HTML, okay. So in this case, if you click this guy, so what you're going to see is this. In fact, this is actually the font, actually CSS, and I can click the date and time. So this is JavaScript code, and then we have a for the graphics file, okay. All right, so that's what we are seeing. So this is what we are seeing. Now, if you take a look at the code, okay, we have a cache file called the mycache1 app cache. And then we have CSS file, my.style.css file, and then we have a JavaScript file. Okay, and then we have 4 images. Okay. Now, if you take a look at the mycache1 app file, okay, so that is basically mycache app cache. So here we basically save only 4 files, so 2 image files, and then 1 CSS file and 1 JavaScript file, and then we don't have anything in the fallback, and everything else has to go to the network. Okay. Now let's take a look at the CSS file and JavaScript file. Okay, so I'm gonna go to CSS file. CSS file is basically, any H3 element will be in red. So that's what this is all about. This guy. So this is H3 element. Okay, so if you take a look at here, that's H3 element. So this is basically displayed in using this CSS file. Okay, all right. Okay. And also JavaScript file is basically it's just displaying the current date and time. Okay, please note that we have cached those CSS file and JavaScript. Okay, all right. Now we are going to take a look at the app cache. Okay, so we're gonna actually go to Chrome. App cache internals. So here, this is actually, the app cache. That's the one, I think. Oh, mycache1 app cache. Okay, so that's the one. Yeah, this is the one just saved. Okay, so if you take a look at the cache file, I mean, this is the cache file. And you can actually see the entries. So the entries are 4 files are cached. This is HTML file itself, and this is the manifest file. The actual data files are 4 of those 8 data files: CSS file, 2 JPG file, and 1 the JavaScript file. Okay, so among the 4 graphics file, only 2, Duke1 and Duke2 JPG files are cached. Okay, the other 2 files are not cached, but CSS and JavaScript are cached. All right, so now what we are going to do, so we have just seen this guy, right? Now what we are going to do is we are going to disconnect. We are going to stop the server. Okay, so this is kind of simulating the offline storage. So we are going to stop the server. So there is no HTTP server that provides these files. Okay, so now we are actually accessing. When you actually go to this page, if I go to this page, oops, I want to actually go to this page. If I go to this page, there is no HTTP server, so it is going to get the files from the local cache. Well, actually, even if you have a connection, it will try to get from the local cache. Okay. So now, if I click this guy, you can see the CSS file still works, and the JavaScript code still works, and these 2 Duke1 and Duke2 files are still there, but you can see these 2 are not there, right? Because these 2 files are not, they were not cached. Okay. So that's basically what we are experiencing here. Yeah. So this is so for your own exercise, you can actually change the manifest file. So you can actually the manifest file, and then let's actually change the save this. Let's remove CSS file. Okay, and yeah. So now when we are trying to access the file, let's see what happens. Okay, that still work is actually because cache. Yeah, so manifest file is actually still cached. That's why. Okay, so what we can do is we are going to actually remove those files. So let's actually go to Chrome, app cache internals, and so let's actually remove these files. Okay, so we're gonna remove. Okay, so we don't have things over there. Okay, so now when you actually go to this page, and okay, so page is not available. Oh, okay, so we don't even have HTML file. Now, yeah, so let's actually run this guy. Yeah, I should actually remove. I'm not sure if we can actually individually remove the file. Okay, so let's run this guy again. Now, if we reload, yeah, things are working fine. But now if I disconnect this one again, and then if I refresh the page, yeah, so the CSS does not work anymore because CSS has not been cached. Okay, so again, if you take a look at the app cache, you can see oops, view entries. You can see CSS file is not cached. Okay. I'm not sure whether you can actually individually remove. Yeah, so there is not a way you can actually individually remove. If you remove it, remove the whole thing. Okay. All right, so that's what's happening. Next, what we are going to do is event. So that is basically what we have done so far, application cache event. So in this case, we are going to exercise event through the event handler. So when you actually restart the server, okay, and this time, we are going to observe we are going to observe from Chrome Developer Tools. So I'm going to F12. Okay, so now we are going to let's see. So we are going to actually go to yeah. Actually, I want to actually go to this link. Okay. Yeah, so that's why. Yeah, the server is not running. That's why. Okay. Okay. So its server is running right now. Okay. So let me just clear this guy. Yeah. Okay. So we'll actually see. So we are going to click this guy, and you can see this event, no update. Okay. And this is actually from the browser itself. Okay. And click this guy, and then we stop this guy. And then when we refresh the page, yeah, application, yeah, so checking and checking cache failed to update. Oh, okay, so that's fine. Yeah, so basically, checking and the cache failed to update. Let's see why we are having this particular error. So it's checking, and this one worked. Let's see. Let's just go back and again, and then we are going to run it again. Okay, so yeah, this is actually what I was looking for. So you can see yeah, so these are the messages coming from Okay, so these are the messages coming from the browser itself. So as I said before, browser will actually fire events whenever state changes. Okay, so these are coming from the browser, and these are from your own event handlers, checking, downloading progress, and things like that. Okay, right. So let me actually show you the code. So basically we have cache handle cache event. Only thing we do is basically display the event type. Okay, so you might want to actually change this guy, just having your name. So let me just change that, guys. This is O1B application cache event. O1B application cache event. So instead of just event type, I'm gonna just say Sang Shin like this. Okay, and save the change. Okay, and let's actually see. So here again, I'm going to 12 and click this guy, and I'm actually looking cache event. Oh, I'm actually looking 1B. Okay, so that's the one. So I save handle events. Oh, okay. So I'm gonna actually the stop and stop and restart the HTTP server. Okay, stop it, and then refresh it. Okay, and then restart the server. Okay, and now let's actually refresh it. Oh, okay. So I want to actually remove the cache first. Okay. So yeah, that's what I have to do. So refresh the page, and I'm going to remove this guy. All right. So that's the one that I want to actually see. Okay. So now I am going to refresh the page. Now you can see these are the messages from the browser. Now these are the messages from my own event handler: Sang Shin checking, Sang Shin downloading, Sang Shin progress, and things like that. Okay. I should actually have a space between Sang Shin and the message. Anyway, so that is event handler. And remove the cache, and then refresh the browser, and then you're going to see these messages and the messages from event handler. So this is from the browser itself, and this is from your own event handler. Okay, cache update. Now, using this browser cache update, so here we click this guy. So there is no update. Okay, so things are working as expected. There is no update on the cache since there is no change in the cache manifest file. And yeah, so you are going to actually see cache no update event. Okay, now what we want to do is that whenever a page is automatically uploaded, we want when the cache is updated, we want the page to be reloaded automatically. Okay, that's not done yet. You have to actually have this kind of JavaScript code. Okay, so basically when update is ready, we want to run this JavaScript function which swept the cache. Okay, so cache update ready, and then we swept the cache, and basically, and then we are going to actually reload the page. Okay, so even if the cache is reloaded, it's not going to change the windows, the page. So yeah, so this is the JavaScript code that actually trigger reloading of the page when the cache is reloaded. Okay, so that's basically what we are doing. So here we are going to add manifest file. We are going to actually add another file called image.duke3.jpg file. So let's actually change that guy. And we are going to have Duke3 JPG file. So we have a Duke3 file as well. Okay, already. Save it. So if you go to image, you can see we have a Duke3 already. Okay. And then we are going to refresh the page. Observe the cache is going to be updated. So now, when you actually click this guy, this page, yeah, so the new version of the update load. And then if you actually see, yeah, I should actually, yeah, so checking update and cache no update event. In this case, we just save it. Hold a second. Cache update. Oh, the first initially no cache up. Initially no update, cache no update event. Okay, and then we are going to actually add this code. Okay, so basically, yeah. So yeah, we need to change this code as well. So this is the once you change application update. Yeah, I think we already have it. Okay, so we have already, we have already have it, and then we changed the manifest file, which we did. So we have that, and we see this one, and refresh the browser and observe the cache is updated. Oh, okay. So basically all you have to do is just refresh the page, and then over here, and then if you take a look at the view entries, now you see the Duke 3 is right there. Okay. Yeah. So. All right, so I'm gonna give you guys, let's see, 3:36. Yeah, so we are supposed to actually start the stub at 4. I'm gonna give you guys about just 10 minutes to try this exercise. Okay, I know that's not enough time. Start again. Next storage type is local and session storage. Before HTML5 storage, cookie was the only storage option available to developers, and but cookies is not really designed for saving data because of that, the cookies limitation. So size of the limit is 4K typically, so you cannot save large document. And the cookies are actually transmitted back and forth for every request. So, basically it's wasting network bandwidth, and also it could be at the point of security risk. So we need the new storage schemes. So we have seen application cache. Now another storage scheme is session and local storage schemes. So session storage is persist as long as the window or tab is alive, meaning that session. Okay, as long as session is alive. Values are visible only within the window or tab in which it is created. So each session will have a different value. Okay, and it will survive page reloading. So even if you refresh the page, the value will be still there. However, if you close the window or tab, then the value is gone. Okay, so that's session storage. Local storage persists even beyond page restart. Okay, the values are shared across every window or tab from the same origin. Okay, so the data is being shared among multiple tabs, and it's good for storing preferences. And both session and the local storage, only string data type will be stored. Okay, so it's a key value pair, and the value can be only string type. All right, so let's do exercise 2. So here, the first is a session storage. So here, if you click this guy, okay, and every time you are refreshing, it increase. Okay. Now I'm going to open another tab. Okay. So I'm gonna, in this case. Now it has its own counter. Okay. So if I refresh, it has its own counters. Okay, and if I go over here, it has its own counters. Now, if you take a look at the actual internal storage, again, you can actually press F12, and you should be able to see resources, and you can see this local storage and session storage. So we are looking at the session storage right now. Okay, so session storage for this is a count of 5 of this, and if I go to different tab. And again, if I take a look at that local storage, it has its own value. oh, this is supposed to, oh, I'm actually looking at the session. I should actually take a look at session. So it should be 7. Okay, so now if I refresh, this keep increasing. Okay, if I go back to different tab, it starts from 5. So each tab should have its own value. Okay, so that's the session storage because each tab is considered as a different session. Okay, now that's session storage. So if you take a look at the code, basically, the way that you are going to use the session storage is basically using session storage, and then this is a key. Initially, we are going to set to 0, and then every time page is refreshed, we are going to increment it. Okay, so pretty straightforward to access it and to change the value. Okay, the next one is a local storage. So in our previous case, if I refresh this page, that value, that session storage is going to be gone. Okay, because each tab has its own session storage. Okay, however, for local storage, now if I go to local storage here, now let's actually keep increasing this guy. So it's going to be 12. Now, if I open another tab, so I'm going to open, so I'm going to open here. And it actually shares the same, the local storage values. Okay. Again, if you take a look at the local storage here, this is 13. And if I go back to first tab and take a look at the local storage, and it shares the same value, 13. So now if I refresh this guy, it's 15. And again, if I go over here and refresh the page, yeah, so it's actually 16 and then incremented by 1, so it becomes 17. So if I go back here and if I take a look at this one, if there is a refresh, yeah, so now it's reflecting 17. Okay. Okay, so that's the session storage and local storage. Okay, so that's basically, so the way that you can access the local storage and session storage is pretty much the same. Okay. All right. All right, so I'm going to give you guys about a few minutes to try exercise 2. Okay, so let's resume. The next technology is IndexedDB. So IndexedDB allows the storage of very large amount of structured data. So these are two distinct characteristics of IndexedDB compared to local storage. Significant amount of structured data. So significant amount, that's one thing, and then structured data. So it doesn't have to be just string type, but it could be just an object. And third distinction is high performance search, meaning it will actually let you perform query operation, and it will be highly performing because it's using index. So you could actually save a catalog of DVDs in the landing library. So it's nice to know that your browser, modern browser, in fact have the database built into it. Okay, in fact it's transactional as well, as we are going to see in a few minutes. So one of the design goals of IndexedDB is to allow large amounts of data to be stored for offline use. Okay? IndexedDB provides powerful query capabilities. All right, so let's compare IndexedDB against the local storage. So local storage lets you store and retrieve data using simple key-value pair, and the value has to be string type only, and it's limited in size. As a default, I think it's 5 meg. IndexedDB is a lot more powerful. It's in fact the fully functioning database. Lets you store a very large number of ad hoc data, meaning objects, and you can actually retrieve the data using robust the data access mechanisms. Okay. It replaces Web SQL. So initially, the W3C was thinking about adding Web SQL as the database into HTML5 based browser. By the way, this is actually relational database type of database. Okay, but it's considered, it's not actually optimized for the browsing environment, so it's actually deprecated, meaning it's dropped in 2010. So instead, IndexedDB, which is actually index table-based system, is actually adopted as the standard database technology, database storage technology for the browser. Okay, so it provides indexing, transactions, querying, and cursor support. However, WebSQL, if you actually go to, for example, the WebSQL is actually still being supported in Chrome. Okay, so Chrome actually supporting both IndexedDB and WebSQL. IndexedDB is the standard. WebSQL, sooner or later it will be deprecated or removed. It's that deprecated already, but it's still being supported within Chrome. Okay. Okay, so inner workings of IndexedDB. So IndexedDB lets you store and retrieve objects, okay, which are indexed within with a key. Okay, all changes that you make with a database happen within transactions. So everything is transactional. Like most web storage solutions, IndexedDB follows the same origin policy. Okay, so while you can access store data within a domain, you cannot access data across a different domain. Again, we're going to actually take a look at the single origin policy issue in detail later on. Okay, so just for now, just remember it is actually constrained by single origin policy. Okay, so key concepts of IndexedDB. IndexedDB database store key value pairs, but the value could be the ad hoc object, meaning complex structured object. Okay, and the keys can be properties of those objects. And then you can create indexes that use any property of the objects for quick searching as well as sorted enumeration. Okay, so it's actually indexed table-based system. It's transactional. Okay, so everything that you do with IndexedDB is in the context of a transaction. So you cannot execute any commands outside of the transaction. Okay, so the use case of this transaction model is like this. This transactional model is really useful when you consider what happens if a user opens two instances of your web application in two different tabs simultaneously. So without the transactional operations, the two instances could stomp all over each other's modification, right? So so in this case, each instances of your web are considered as a different user, right? So you certainly want to perform the database operations in transactional manner in this case. Okay, so IndexedDB API is asynchronous. Okay, so the way you are going to use IndexedDB API is asynchronous, meaning you ask for a database operation like a save, and it returns right away. Okay, and you have to provide the success callback and the error callback, and those success callback and error callback will be invoked later on after operation is done successfully or when error occurred. Okay, so this is not synchronous the operation like SQL. Okay, in SQL you actually invoke for example like a JDBC in your Java code. You call JDBC API and it doesn't return until JDBC database operation is complete, right? IndexedDB is that's synchronous model. IndexedDB is asynchronous model. So in JavaScript, everything is asynchronous model, right? You call save method, save operation, and then you provide callback functions. Okay, so that's the way things work. And we're gonna take a look at the code. Okay, so how to use it? First, you're going to open a database and start a transaction, and then you create an object store. So you can think of object store is like the database. Okay, I think we have actually slide that actually okay. So I thought I actually have a slide that compare between the two. Okay. Make a request to do some database operation like adding or retrieving data. And again, that's async method, asynchronous model. And then you wait for the operation to complete by listening to the right kind of DOM event. Okay, DOM event could be success or failure. Okay, and do something with the result. So in your callback, success callback function, you're going to actually do something with it. Okay. Okay, structuring the database. So IndexedDB does not use structured query language. It's not based on SQL. It uses queries on an index that produces a cursor, which you use to iterate across the result set. Okay, and IndexedDB uses object store rather than tables. Okay. And a single database can contain any number of object stores. So you can, so you can think of object store in IndexedDB like a table in a relational database. Okay. So whenever value is stored in object store, it is associated with a key, and that is going to be used for later on for the highly performing query operation. All right, so let's do exercise 3. I'm gonna just demonstrate it. So here, we are going to click this guy, and then yes, you can take a look at the what gets created underneath. Okay, so let's actually play around with this. So we are going to let me just open the console and create. Okay, so we have we created database, and we created object stores, and database created message. Okay, so now if you take a look at these resources here, and then go to IndexedDB. Okay, so for now it doesn't show. Okay, so now let's populate database, whether that works. Yeah, this code is a little bit shaky, I have to say. Maybe open the database and populate database. Let's delete this guy first, and then open, populate. Okay, so edit. Oh, okay, so now, so edit and deleting database, populate database, fetching all employees. Yeah, so things actually now why it didn't actually display. Yeah, once it's actually so go to resources. Oh, okay, IndexedDB. Okay, now, yeah, so okay, so now things, so it looks like it was actually a little bit slow. So employee DB, and actually, oh, okay, so now I'm gonna actually populate it. Okay, so let's take a look at the, so we create database, we do new version, inspect, so we should actually see this employee here, employees, and we can actually observe the file here. I'm not sure it's actually in conflict with whatever file I happen to have, so I might actually delete this file. Okay, so let me actually explain these things, and I'm going to try one more time. Okay, so this is for creating of the database. So the local database IndexedDB is Windows IndexedDB, and then you create a new database. So open database name. Database name is specify employee DB here, and the version. Okay, and then we basically call create object store. The object store is called employees. Okay, and then we have to create multiple indexes based on state, email, and zip code. Okay, so that's creating. Now, when you populate it, it should actually populate the employees like this. Okay, so it actually populated with 5 employees. Okay, and so this is actually, so we actually start with a transaction, and we get the object store. So transaction.object store, and the name of the object store is employees. And then we are actually we are calling a put method, and this is the the JavaScript object literal. Okay, so this is actually the first employee object. Okay, and so you can see this is actually when you call the put, it returns right away. So this is the request object, and then for that request object, we are going to actually provide the callback function. So we are providing a success callback function and error callback function. Okay, and in a success function, basically we just display added E1. So that's why you're actually seeing the messages in the controller added E1. Okay, so yeah, so it actually the console. Oops, not this one. I'm gonna actually try one more time. Oops. IndexedDB. So I go over here. So data is not populated. So I'm gonna delete this guy. So deleting database, all database deleted, and then I'm going to actually open database with the current version. So opening database with the current version, if the database is not present, it's going to create one. Okay, so database opened. Okay, now we are going to, let's try to populate. Okay. One of the specified object store was not. Okay, so looks like we didn't actually create the database correctly. So we are going to try this one, creating DB version and then populate. So this is the one of the specified object is not. Okay, now we can actually open this guy and then populate. Keep having that problem. This is not good. Let me just refresh this guy and failed to execute transaction ID be able this specific object store was not found. Delete. Create. Yeah, so we create the brand new version and then populate. Oh, open. Then populate. Oh, now it works. Yeah, so I think I have to actually create the new version of it. Okay, so now things are populated. Now I can actually, the fetch data, fetching all employees, and I can fetch by email. So let's take a look at the index here. Yeah, still not good. Still not. Refresh. Yeah, so all right. Yeah, so what happened? What's supposed to happen is to fetch all employees. It's actually display all these employees that are populated first, and then I should be able to fetch. Again, fetch is basically you call the open cursor, and then you provide the success event handler, and then we just display the each of those employees that are fetched. Okay. Okay, so my apology for not actually making things work as specified in the lab documentation. I think in my browser there was some inconsistency, something. You probably have a better luck, okay? All right, so let me actually finish up the presentation. Next one is a local file system. So file system APIs are provided. So web application can create, read, navigate, and write to sandbox section of the user's local file system. Okay. So this is for 3 different types of file system APIs: file, blob, file list, and file reader. And creating and writing blob and file writer, and then you can also actually manipulate the directories and file system access, directory reader, file entry, directory entry, and local file system. You can actually take a look at the file system support. So right now it's actually being supported pretty much. It's actually still pretty low, like a 44%. Okay. All right, so if you take a look at the file system API, so let's take a look at the file system API. If you run this guy, we can actually add some files. So files created, and you can list the files and remove all files. Okay, and then you add again, list files, and remove all files. Now, if you try to list the files, file system is empty. Okay, so if you take a look at the code, so basically add some files. So get file, and so basically log that text file, song.mp3 file, and things like that. Okay, so we are basically creating files. So if the file is not, so when you try to get the file, if the file is not present, create true. So this is an attribute. Okay, this is a listing of the files. Okay, and this is removing all files. Okay. Yeah, for now, as long as you understand that there are actually file system APIs that are available, that's pretty much good enough. Okay, and the database has been created under this location. Okay, so local Google Chrome user data default file system directory. There is actually interesting the application. So if you click this guy, you can see this is like a browser, and it looks like a Unix shell. So you can say ls, okay, and because it's a browser, you can actually the import project. So I can actually go to some file system here. Let me just import HTML3.3d file. So I can actually click this guy. Oops. Edit. Okay, so let me go to temp, and now let's actually see if I can copy this guy. File edit. Okay, so now you can see HTML5 3D PDF file is actually present. Okay, so this is actually browser based, the file system shell in a sense. Okay, and because it's browser, I can actually do drag and drop kind of thing. So which is pretty cool. Okay, so you can try that. The next one is Quora, the API. So you can actually ask for the storage. So basically call query. You can query. This is for querying, and this is for requesting. Okay. So for querying, you like to actually know I like to know the temporary storage. And then if it is successful, I want to actually display the used and remaining space. Okay. If there is an error, then I want to just say error, display the error. Okay. So that is query usage and quota. And this is for asking for more storage. So you can actually specify type of the storage, and then you specify the size, and then you specify success callback. So here I want to ask for persistent storage, and this is the size of the storage I want, and this is the success callback, and this is error callback. So in this case, it will pass me the used disk space, including including the space that was asked. Okay. Okay, so that's exercise 5. So here, so I want to actually show the temporary storage space. So right now, it's used is this much, and the bytes remaining is this. Okay. Now I'm going to ask, let's say, 10,000 bytes, 100,000 bytes, and request quota, and then it's asking me, it's actually asking for the permission from the user. Okay. Then if I say OK, then it's basically the size that has been actually allocated. Okay. Let's see. That's quota API. Online offline event. Sometimes you want to actually see how things are connected or not. Okay, so let me actually use the slide. So that is actually what is called the online property in the navigator object. And the events online offlines are fired when the value of this attribute changes. Okay. The attribute is inherently unreliable. Computer can be, so the thing is that the definition of online offline is kind of still vague. For example, you might in fact have a wireless connection, but you might not have internet connection, meaning you might have wireless connection, but not internet connection. So does that mean it's offline? So the clear definition is not there yet. Okay. So in fact, the Firefox doesn't support this one. Only Chrome sets this guy. So only Chrome sets navigator online offline property, and then it will actually, whenever this property changes, event will be triggered. Okay. All right. So this is the code that we have in our exercise. So whenever online the event occurs, we want to call this display status function. This is event handler. Same thing for offline. And here basically we check online property, and if we just display online in a location. Okay. All right. So that's exercise 6. So here in exercise 6, right now this is online, okay? But if I, make a if I disconnect the internet connection, which I don't want to do at this point because I'm gonna lose you guys, right? Then it will actually display offline, okay? And then if I reconnect, then it will display online again, okay? So that's basically, so it's online. I disconnect, then it will, offline. And then if I reconnect, then it will be online again, something like that. Okay, and the code is pretty much if you take a look at this code. Yeah, so that's the same code that I showed you in the slide. Okay, so I'm gonna actually ask you guys to try that yourself. Okay. All right, so that is the end of the presentation.